Hi everyone, welcome and thanks for joining us in your precious Friday lunchtime. And that thank you is obviously extended to our guests as well as everyone who's listening in. And then there'll be a fair few of you that'll be watching this as the sort of edited webinar highlights. So this is our sort of Friday certs debate. We've got something that's very much on topic, which is around what we're calling sustainable digital infrastructure. So what I'd like to do is I'm going to introduce you to our panel in a second. But before I do that, I just want to remind you all that it is interactive. We've got a chat window at the side, so you guys are able to put in a question, and then I will do my very best to keep an eye on those questions. And you can ask the panel generally, you can ask anyone individually, and we'll make sure that we cover off those questions as best as we can. I think the other thing to do as well is we've got the topic sustainable digital infrastructure. We're going to sort of switch it around a little bit. We're going to attempt to sort of a definition of that towards the end, because I think it'll be the discussion that we have between all of us that will then sort of probably give us a good idea of what we mean by sustainable digital infrastructure. So we've got some fantastic guests. I've been on one session previously with Leon, but it's the first time I've met Astrid and Jason. So welcome all of you, and thank you very much for joining us. What I've done is I've just done alphabetical order on first name. I thought, that would be fair. So Astrid, I suppose whenever that happens, you're always first. You have a chartered qualification as well, specifically within the sort of environmental spaces, which I'd not seen before. So it'd be great for you to give us a background on your passion and maybe a little bit about the institute that hands out that chartered qualification. Over to you, Astrid.
So I guess I should start with my IEMA is. I'm a chartered environmentalist. I'm given that qualification through IEMA and the Society of Environmentalists. What that means is that they assess your past history on research and spreading sustainability culture into organisations, leadership, things like that. And they give you an interview and they marry that up with their parameters, whether they think gives you chartered status. IEMA has been in existence.
Sorry, Astrid, we're just getting a little bit of delay with you. Keep going, but if it carries on, I might ask you to turn your camera off and then we'll go audio only. But at the moment, I'm just talking with Leon and Jason. Can you hear me okay?
Yes.
Okay.
I'll just
it might just help with the recording. Sorry, Astrid, go for it.
Okay. So IEMA is the Institute of Environmental Management and Assessment. Has a background in being an environmentalist organisation. It moved into sustainability. It's got a wide range of industries involved, from people who look at biodiversity, replanting hedgerows, for example, right through to people who are thinking about chemical sustainability, me in the middle, electronics. I was given the chartered status through work I've done in the field, predominantly in circular economy, for IT hardware, and then trying to marry that with energy efficiency through a number of research projects that we ran. I like IEMA because it has a broader approach than just carbon when talking about sustainability. It's got a long history of operating, so it's not jumping on legislation that's up and coming now or issues that are in the press now. It's got a wider approach that looks at all sustainability issues as well as carbon, and looks at sensible approaches to that. And we run training.
So Astrid, we're having we're not getting all your audio coming through, unfortunately, but I just want to sort of summarise what I picked out of that is particularly the point that you're talking about, the circular economy, and also that it's not just carbon. Because I think a lot of us, when we first look at this topic, from what you've picked up in the news, or if you're sort of like a layperson, it's definitely, you're talking about carbon footprint. That seems to be the normal thing, but it's much wider than that, than just purely has, I suppose, we should just define what carbon means, but I presume that means just an energy source that's come from coal or something that produces carbon dioxide once you use it. Would that be a fair summary, Astrid, of what you just said?
But I would clarify what carbon means. So carbon is a currency. When we talk about CO2 equivalent, we're basically talking about all greenhouse gas emissions.
Yeah.
So it would be the F gases, it would also be methane, a lot of the refrigerant gases as well. So there are 7 greenhouse gases that we talk about when we talk about carbon equivalents, and they all have different intensities. So yeah, that's what I mean by carbon. I mean greenhouse gases.
Okay, thanks, Astrid. So we'll come back to you in a second. I'm just going to move across again in alphabetical order. So Jason Liggins, you're working in the UK public sector, Crown Commercial Service, I believe. It'd be great to hear a bit about your background, and also I was thinking, given Crown Commercial, their role, it'd be really interesting to see whether there is a trend, for the importance of sustainable technology, when the government's deciding, what it's going to buy, what sort of weighting it gives it. Is it something that's becoming more prevalent, or, but before you get into that, apologies, Jason, do you want to introduce yourself and give us a little bit of your background?
Yeah, sure. Thank you. Good afternoon, everybody. So I'm a technologist working within the digital futures team of Crown Commercial Service, and specifically the Crown Hosting team. And my role is to help public sector organisations that want to make use of the frameworks that CCS produces to enable them to buy technology, help them decide what it is that they're trying to buy, what their problem is, what they're trying to solve, and then how to solve it and how to buy it. And so those are all those things. And so I'm a technologist. I've a few decades now working around technology, specifically infrastructures that go into data centers and cloud platforms. A platform is just it is somebody's data center somewhere, and so it's been able to balance the demands and needs of customers with appropriate solutions across the different sorts of technologies that you can possibly buy. In answer to your question regarding sustainability, it's front and center with all technology procurement, and all procurements now within certainly within central government and in the wider public sector. We've committed in law to reduce our carbon dioxide equivalents to zero, but the forthcoming decade. So we've got quite active requirements across all suppliers to public sector to support those initiatives, and so it's a very important part, especially of technology procurements. We have transparency objectives, so all suppliers are required to be quite transparent about some of these things, and we include the reduction in carbon and when we talk about carbon, it is carbon dioxide equivalents that we're talking about over that period. And it's not just public sector's use of carbon, so their own electricity consumption. It's also the carbon produced by the suppliers themselves. So everybody needs to be working towards that goal.
Yeah, and I suppose, Jason, it's a really good example of where government can actually make a big difference, because you're able to drive all those behaviours within the supply chain, and you can show quite a bit of leadership and steering, like you say, the supply chain, not just internally. Okay, well, look, Jason, we'll come back to you. Thank you for the introduction there. So, Leon, we've met before, previous webinar. We're not in real life yet, but thank you very much for joining us again. Now, you have extensive data center experience. You're very passionate around energy usage. I'm basically doing a bit of a summary for the last time we met. But for those of us that are watching the webinar and haven't seen the previous one, would you mind giving us a bit about your background and your passion and your interest in this topic that we're discussing today?
Yeah, sure. So I'm Leon O'Neill, and I'm talking on behalf of the Data Center Alliance today, which is the UK trade association for the UK data center sector. We get involved in talking to government and helping them understand what digital infrastructure is, because they're not really clear on where to put that within government. We help and advise end users on where to buy or where to get information from about their strategy. And we work with co-location operators, equipment suppliers, OEMs, manufacturers, and help connect the dots when it comes to projects and other activities within the data center that's going to impact their business. Second to that, I have my own little consultancy practice, which is Digital Aboards. Digital Aboards is really focused on connecting those dots. It's more a business development activity. And I'm very passionate about helping the data center industry achieve a number of targets that are set for us around net zero, and really investigating technologies that might exceed net zero and presenting them to the market as potential solutions of the future. My overall dream is to get renewable energy companies co-investing and cooperating with data center operators to deliver data and energy hubs throughout the UK. And that's kind of my dream. That's me in a nutshell.
Brilliant. Thanks, Leon. And I'm thinking that level of coordination is probably going to require some public sector steering as well, either in sort of the capacity that Jason's described, or at some sort of legislative or some sort of strong direction of travel. And I think that's part of the challenge that the discussion we're having at the moment. I suppose we want to make sure it's as clear as possible. But I think if we were having this discussion in some boardrooms, even at the level we're talking about, it might be deemed to be too sort of technical to understand. Now, I'm not trying to make boards out to be sort of unintelligent, but it's a real challenge within boards to understand technology. So just wondering whether Leon or Jason, either of you, have had experience of trying to translate part of the topic that we're going through at that level where senior management really do understand, what it is we're actually talking about, rather than it's all just a bit too difficult to get our heads around. Because isn't that part of the challenge here, it's such a big impact, what we do with the planet. But when we start to get into any level of detail, it seems, even, in the climate elements, it's got this complexity, which sort of almost allows some of us to say, well, I don't really understand it, so I can't really do anything about it. So in terms of getting that message across, Leon, first of all, how do we do that? What's the sort of the communication tricks? How do we build up that movement?
Well, thankfully, particularly when you talk to the C levels within the suppliers and the co-location operators, most of the C levels are quite tech savvy, and what they don't understand, they have a team around them that do understand. And then through the Data Center Alliance, they've got access to resources that can support and help them in trying to achieve and understand their goals. So the message about the importance of this is not as difficult as it was, say, 5 years ago, because people are conscious of it and people are aware that they need to do something. So I think as a sector, as an industry, we're pretty good at understanding what we need to do and how we need to do it. The question probably comes around, do we have the technology to do it, or where can we find the technology and the expertise to merge what we're trying to achieve together?
Cool. And Jason, do you pick up on anything wider, around in the role of government to be able to nudge us along in terms of building this momentum, so that we're starting to think joining up data centers with power providers, planned regionally? I mean, Jason, I know this is a really big question, but it's more of your sort of whether you move in those circles or you hear of those sorts of things.
So I think the link between certainly between technology and the carbon production from technology and energy use is well understood. So IT uses electricity produces carbon, and that is that link is quite firm and not a difficult concept for our execs to understand. Where they have is a lot harder for them to get a handle on is embedded carbon, and so it's and this speaks to a bit about the circular economy of IT, because there's energy producing that IT in the first place, and do we account for that in our when we're buying new IT? Do we account for the carbon associated with that IT, or would it be better to do the circular? And you've got to balance that off across the energy use of that IT. Is the new IT more energy efficient than the old IT, and where does the two graphs?
So Jason, sorry to interrupt. So just you used the term embedded carbon, and then you used the term circular. Could you kind of just explain the differences between those terms for the audience, and actually also for me? I can take a guess, but I don't want to assume I know what that is.
So when you make something, when a factory produces something, it takes energy, or there is energy used in the extraction of the materials from the environment. So you mine up for metals, that takes fuel for vehicles and things like that. So it has an environmental cost, and we can measure that in carbon dioxide equivalents. Similarly, when you process those raw materials, that has an energy impact, and you can account for that. And so what you get at the end of it is a product that has had a cost in carbon dioxide terms, or carbon dioxide equivalent terms, that we call that embedded carbon. So every time we replace something, there has a cost associated in that embedded carbon, and the circular economy is referring to the recycling, the reuse of IT. So if you've got a piece of old IT that's no use to you anymore, can it be refurbished in a way that it is useful to somebody else? And so rather than waste throw that embedded carbon away, sending it to landfill, can somebody else make a longer use of that equipment, so that they're not having to buy new and have that associated cost of that embedded carbon? So that was quite long.
No, that was great. So Jason, I'm just because I noticed Astrid is back in, and I know Astrid might want to talk about the refurbish options, but I'm just going to test Astrid's connection. So Astrid, can you hear us okay?
I can hear you fine. Can you hear me better now?
Yes, we can. So I don't know, did you pick up the point Jason was just making around sort of the opportunity to refurbish technology, rather than, I suppose, putting it into landfill or creating another kind of embedded carbon?
I did. Yes, I did. I thought the explanation was great.
Cool.
I think what I would add to that is that circular economy is not just about recycling and reuse. There are lots of models in circular economy. And they've got different values associated with them. So reuse for IT especially would be a highest value model for circular economy, because it means that you're saving all of the energy that went into the production of the equipment and 100% of the materials. Then you go out and you look at remanufacture, which for IT equipment often means reconfiguration. The energy cost of that is quite low. Jason was talking about balancing the cost of energy that you use in use phase when you plug the equipment in against the cost of energy that it took to produce the equipment. We specialise in this. We did a 2-year research project looking at just this, looking at looking at the differences between generations of IT equipment and what difference in energy efficiency was between those generations. We found out that Moore's law is non-existent now, but it's It's declined for CPUs, which is where most of the energy usage comes from in servers, which opens up more opportunity for circular economy techniques. And that doesn't just mean using refurbished machines, it means upgrading older machines with higher level CPUs and additional memory, and then getting a machine that can outperform the base generation, the base configuration of a new machine. So it's quite a complicated approach. It just means that you have to measure everything accurately, and that's what our tool has been developed to do. So it looks at energy efficiency for all makes, models, and configurations of servers, and then it will do a cost and energy analysis at the time, and also build in the embedded carbon into that, so give you a carbon figure. I guess the barriers to circular economy are not just around energy efficiency. People are concerned about the data that all the devices bear. And there are standards that exist that means that you can handle that data loss risk. So there's software available that's been approved by National Security Agency in the US, for example, and there are systems in place through certification is now on public tenders that looks at secure chain of custody for data-bearing devices. Yeah, but I agree, it's a balance. The other thing that I would add to it is when we're talking about environmental damage or environmental risk for IT hardware, we're not just talking about carbon equivalents. We're also talking materials risk. So there are a lot of precious metals and rare earths in our IT equipment, which are destroyed by conventional recycling technologies and are in low or politically unstable supply. So unless you find a better way of extending product life and maintaining those materials for longer, you risk running out, especially because the IT sector is growing, so there's an increased demand for those materials, and the renewables sector is also growing and they want the same materials. There's evidence that we can get there with recycling. There are recycling technologies that are in development now, which would be much more efficient, covering lots of materials from the same equipment, avoiding materials loss. But we need to buy those technologies time to come into the market and be viable at commercial scale, which is another reason why you'd be looking for product life extension as much as possible for as long as possible by that time.
Cool. So Astrid, a lot to unpack in that. So thank you very much. So I've just been taking some notes as we've gone along. So the first thing is Moore's law. Not everyone on the call will know what Moore's law is. So correct me if I'm wrong, but I think it's basically over a period of time that the capacity of a computer doubles, but it costs kind of halves. So you've got this initially this sort of arms race of additional processing power that went on through the 90s. But actually, as with everything, you eventually hit the buffers, you get diminishing marginal returns. We're not really seeing that moving. That's made me think of something totally different. So has everyone heard, this is going to need to be fact checked, but you know that sort of saying, which is 80% of most software isn't ever used. So most of the stuff we use is massively more features than we actually use ourselves. And for any of us who are long in the tooth enough, I'm one of them, to think about very, very early word processors. And I think about what I used them for on that really early days and what I do, today on a word processor. I wouldn't say there's a huge difference. There are some notable differences, but broadly speaking, it's the same thing. So I'm wondering whether there is another mechanism at play here that we haven't looked at, which is, can we not just challenge the need for increasing CPU power? Isn't that being driven by the software? And look, this isn't a conspiracy theory channel or anything like that, but is there a scenario where actually creating more complicated software actually drives the need for more hardware, and there is a sort of a commercial embrace that then the two sort of drive each other? And what we're trying to do is sort of deal with the symptoms of all of that. Whereas actually maybe we should be looking more about what's the climate impact of a major software upgrade. Leon, I'm going to throw that one at you. So just, think of, I don't want to name any actual names, obviously, because there's lots of different things. But if you think of a new operating system that gets launched, what is it really giving us versus previous operating systems? And is that difference worth the environmental impact? Because, we've got thousands of laptops that need to be, cycled out, or, that I'm just trying to work out. It's a slightly different angle here. And if anyone says, oh no, you've got to keep them secure, the decision to stop patching on a particular operating system is a decision made by humans. It's not driven by climate change. So I was wondering, Leon, I haven't prepped you for that question, and I might ask other panels, but do you have a take on that, Leon, or do you think we've just got to keep up with the pace of change?
There's an argument within the data center operators community that says that hardware should be focused on in developing hardware that's better and more efficient, and that would be some would say in the community, and I'm talking about seasoned data center professionals that have been in the industry for a long time, would say that it's the responsibility of the hardware developers to get developing their hardware. How easy that is, I'm not entirely sure. With the circular economy and the refurbishment of equipment, and as Astrid mentioned earlier on, how there's technologies coming through that will improve that. What does that mean to the bottom line of the major hardware manufacturers? And should they be actually investing or focusing on changing their business model to be more about the circular economy? It's a difficult question to ask to answer, given that each business has a different business case for upgrading or changing an application, and what the infrastructure is required behind that is really a decision within that IT infrastructure department of that organization. But I would always recommend that IT departments speak to organizations like TechBuy and look at the many different options that they can show to them, and also speak to co-location operators like Jason, particularly for the public sector, about what could the infrastructure look like within the data center that will support and be more efficient of the hardware that they're going to upgrade for this new application. And again, it's all about communicating within the sector. So from the Data Center Alliance's perspective, throw these questions at us, and we will go to our community and ask them what their thoughts are, and come back with some valid points and valid advice that they can use to inform their strategy.
So I'm going to go to the panel one by one on Zoe's question for quick wins. But before I do, and to give them a chance to read that question and before I ask it, just a quick one, Leon. Now, I might have got this the wrong way around, but when you look at data centers, there's a tiering. I think there's a standard like a tier 1 to tier 4 or something like that. If you think about the team that runs their own data center, so it's a classic sort of on-premise in-house team, if they're getting into anything above tier 1, tier 1 dot something, they're probably doing really well against the vast majority of folks who have got a limited number of resources, etc. I don't think that if you take that resource constraint of your in-house team, that and I don't know whether tier 1 has any kind of environmental energy efficiency angle to it at all. And equally, I don't know whether T4 is bringing all of those things into play, or is there a new tier 5 that we need, which is all about we've got the most efficient hardware, we're consuming electricity in a very clever way, etc., etc. So is there a constraint that you think realistically teams aren't going to be able to? Because the reason why I say it, Leon, is I think there's a lot of teams right now are looking at the electricity bill.
Yeah.
Lots of folks are coming out of tariff, and costs are going up 200, 300, 400%.
Absolutely.
So suddenly it's a sort of landing on the desk. So I wanted to get your view on that, Leon, and then we'll go to Zoe's question, which is about the quick wins. But Leon, just on that sort of, what can you do? Yeah.
Well, I'll quickly just explain what the tiering system is. So tier one, there's a number of different elements that make up the tiering, and how you get the tiering accreditation is how well you perform against the ticks in the boxes. But if you think tier one is the least redundant, or least investment required in the data center, and a tier four is the most investment required in a data center. Most co-location operators sit in the tier three bracket, and most privately owned data centers, they will probably sit between tier two and tier three. But there is an argument, particularly with around sustainability, about whether the tiering is relevant in today's market. So if you've got your own data center and you're not essentially a technology company or an IT company, or you're hosting other companies' data, the question I would ask you is, why do you have one anyway? It's not your core business. And there's plenty of absolute experts out there in the market, i.e. co-location operators. Jason and the guys at Crown Commercial, particularly for the public sector, are experts in this. And it makes sense for you to outsource your facilities, your IT facilities, to a co-location provider who does this day in, day out. So that would be my first question to anyone that's concerned about what they're doing correctly within their data center. My first question to that end user is, do you really need a data center? And let's look at the options available to you above and beyond what we call the hyperscalers. Look at independent operators and look at specialist operators as well. And from there, you can formulate a strategy that actually works for the business outputs, rather than, oh, we've got a nice shiny data center. And just to add to that, there is plenty of activity in the M&A market where data centers that are owned by end users are being bought out or bought by co-location operators and being converted into co-location facilities. That is a huge market at the moment. So if you do own your own data center, it's something worth having a conversation with the Data Center Alliance, as we can guide you through the options for you so you can make the right strategic decisions going forward for your business.
Great. Thanks, Leon. So I'll start with Astrid. So I'll just read the question out from Zoe, which is there anything businesses can do straight away, it's those classic quick wins that we like to try and find, to help towards a more sustainable digital infrastructure? So Astrid, if I could start with you, just in the quick wins, and it seems a bit contradictory to talk about quick wins and climate because of the nature of the change. But can you hear me okay, Astrid?
Yeah, I can hear you fine, thanks.
Thank you.
Because at first thing, I'd just come back on quick wins and climate. I don't think there is a tension there. I think the more steps you can take immediately today when it comes to energy efficiency and materials efficiency, the better, really, especially because carbon capture technologies, for example, are a longer term play. You need to be looking at reductions and efficiencies right now, in any way that you can. So quick wins, look at energy efficiency. That is the key thing I would suggest. There are metrics out there that can help you. There are tools out there that can help you calculate the energy efficiency of your servers. There are also awareness programs that are being run by people like DEFRA on being responsible digital citizens, and just top tips. For example, if you're video conferencing and you don't need to see the other person, you can turn your video off. That will save 90% of energy in some applications. Aside from that, if you are an organisation, I would advise you to look at where the IT is going when you make that IT redundant. It's startling and quite depressing how little attention is paid to that, even by technology providers. It does end up in landfill, or it ends up being carted off by a general recycler. sometimes that equipment will be in working order. So look at ITAD providers. They are IT asset disposition companies. They give you certified data destruction. They'll also take care of the compliance risk for GDPR. And they'll try and ensure that it goes to at least recycling and hopefully to use. So that's another top tip. Leon's already covered data centres. I'd also highlight that data centres don't just have standards around energy efficiency. The Data Centre Alliance also has standards around carbon efficiency, around IT efficiency, around water usage, effectiveness. There are a whole host of standards that the data centre sector is aware of and is addressing. So look for companies who are doing that. And also don't be afraid to ask questions of your supply chain. That could be your cloud provider or your data center, your managed service provider. It could be the people who are selling you the equipment, and it could be your downstream service providers. So ask questions and see whether you can improve every step as much as you can. I don't know if they're quick wins.
That's great. Thank you, Astrid. I'll just jump over to Jason next, and then to Leon. So Jason, just in terms of what you've heard, are any other quick wins that you would send out to the audience?
Yeah, certainly. There's a couple of really ones I use a lot, and one is to do with the utilization of the server. So if you've got and where you put that server, the physical facilities. So Leon perhaps will be able to comment on what the proportion in the UK of IT is in on-premises facilities, so server rooms in offices, as opposed to co-location. Is probably better placed than I am to know what the current percentage is. But my rule of thumb from a few years ago was 70% of IT that's not in public cloud premises is in small server rooms in people's offices. So this is facilities of 100 racks or less, typically less than 25. The efficiency of those sorts of facilities, because of their nature, the size is just really poor, really bad. We use a metric PUE in the industry, which is it's a combination of how much electricity is used by the IT and how much electricity is used by the building to support it. So for every £1 of electricity you put into the IT, and there's a proportionate amount of electricity more that's used in the building. So a PUE of 2 means £1 for the IT, £1 for the building. And if you've got PUE of anything higher than 1.7, then it's not looking good from a sustainability and efficiency perspective. So relocate that IT somewhere else where it is better. That's the first quick win, and it's not hard to do. The risk associated with it is not as high as people would think. The other thing to think is go back to that server utilization. If your utilization of a server is in the low percentages, and I see 1 and 2% utilization over time as a figure given to me, then that server could be doing so many other things at the same time, or at other times of the day, and other things. You can use virtualization technologies, go on that digital journey to share that server with other applications. And ultimately, that's what we do in public cloud, what our big hyperscale providers do. They share the IT amongst many customers all at the same time to get a much higher utilization out of the servers. And what we're trying with our digital maturity for everybody is move everybody along that journey, and it's to overcome our fear of using the same IT equipment for multiple things.
Can I just add into that? I think they're great points that Jason's made. Other things that I would look at on the servers is check your BIOS settings. A lot of servers are shipped in performance mode. We've just written an academic paper that demonstrates in most cases you can get to that 100% performance still in efficiency mode, and it will save you an awful lot of energy when you're operating at lower utilization. So that's something that's a real easy, quick win. Change the BIOS setting in the servers. Another thing is look at the energy efficiency server by server and configuration by configuration. It's quite a new concept, but that's handling the one in your PUE. It's handling what the IT is actually doing. And there are tools on the market.
The power management tools that you're talking about there, Astrid, are really important, because if you can get the IT to turn itself off or like power down during its working life, so that it's not using so much electricity when it's not got so much demand on it, and that's more than just the CPUs. That's the fans in the equipment as well. So that reduces your overall consumption of electricity by the IT. That one. And then you need the data center to be able to pick up on that change and adjust the amount of cooling that it's applied to the server. So you also reduce the amount of energy that goes into the building supplies to cool the IT. And that's it. And that's what the Open Compute standards for data centers, that's what they do.
Yeah, absolutely. And also look at configuration of machines. So, the IEEE Transactions on Sustainable Computing that we published demonstrated that you could get a Generation 9 server outperform a Generation 10 server by 36% by changing the CPU and doubling the amount of RAM. These are small changes. They result in massive energy efficiency gains.
We've all done that at home. Those of us in the know, that's the oldest trick in the book. That is, give your machine a fresh life. But can I just throw a couple of things in? So, look, absolutely fascinating. I'd never heard of PUE before, Jason. I'm just wondering whether the 1.7 might be a bit tough with inflation of electricity. So we might need to do an adjusted PUE because the inflation, the cost of electricity is going up so high. I get your point, though. I'm just saying, would we need to look at a slightly different ratio, given that electricity costs are going through the roof? It's still the same point that you're making. I'm just saying, would it still be, got that underlying electricity inflation going on?
So it's a multiple
Okay.
a PUE. So whether you're paying £1 for a unit of electricity or £10 for a unit of electricity, the multiple doesn't stay the same. What you need to do to reduce your overall cost is get that PUE figure even lower.
Right.
So rather than being 1.7, below 1.5, below 1.3, and it's a it's a physics ever diminishing returns as you get lower, because it gets so much harder to do as you get to a lower figure. But from an energy usage perspective, and the amount of not just pounds that you spend, but all the carbon that you produce as a result of using that energy is reduced, the lower that you can make that PUE figure.
Cool. So we've got a question around sort of power source, which I'm going to introduce sort of towards the end with some other discussion around sort of alternative sources of power. But before we go there, just on the maturity assessment that you guys are talking about, if you're in the public sector, Jason, I presume it's a pretty well-oiled route to contact you guys and to have a look at the setup in particular government departments, etc. What about the private sector? What about the big group of, well, I say big actually, sorry Leon, I don't know what the numbers are, but I'm just trying to think of all the folks that are still running their own data centers. They're doing their very, very best, but they probably aren't in any alliance. They don't have the sort of the coordination that's coming from people like Jason to get the most out of the public pound that's being spent. So what's available in the private sector other than maybe Jason sending me a letter saying, hang on a minute, you're in our supply chain, we don't like that sort of stick approach. Is there any resources available to the private sector who can reach out to get hold of these best practices? Yeah. Whilst they're still trying to sort of work out what their overall data center strategy should be as far as its impact on climate, etc. Sorry, Leon.
Yeah, sure. Again, the Data Center Alliance, being a non-profit organization, is there for people to ask questions, pose those difficult difficult questions that they don't know how to answer or where to go for resources. By being a member of the Data Center Alliance, we're able to then put them in front of the likes of Catherine or Zoe or Michelle that's watching this panel right now, and point them in the right direction to organizations that can help them with those questions. That's the value of the Data Center Alliance. It's not just about those that work in it; it's about those that need help from it as well. So there's lots of resources available. It's just got to know where to find them, and the Data Center Alliance can help you do that, regardless of what the challenges are.
Cool. Thanks, Leon. So I wanted just a couple more topic areas to go in, and obviously we'll take questions as they come in. But Michelle had mentioned, is there a case for more solar power in government buildings to support where we're getting power from? I wanted to just introduce that into a slightly wider thing about, are we going to break out of the carbon dependency? It is literally one of the most important questions of our time.
Yeah.
If you are someone who keeps an eye out on LinkedIn and email, so I'm not saying this is by any way a good way to research these things, but I get a feeling that hydrogen's starting to creep into the news feeds a little bit like EVs were 10 years ago. And there's obviously a lot of misinformation when you look online how far we've actually got down the road or not. But if we made a transformational breakthrough and we were able to have hydrogen power and any other non-carbon based supply, well, is that a complete game changer for us, or actually? And I'm just thinking, Astrid might say, well, it is for power consumption, but there's still all those other impacts that we make on society. But just on the power side, how great would it be if we had a hydrogen breakthrough?
Well, there's still always the concern of the danger of hydrogen. That will always be in the back of people's minds. And if we could flick a switch and find a way to generate emission-free power, that would be the game changer that changes the world. But then some people might argue that actually that will put an imbalance on the global economy. It could impact the global economy quite badly. But when the problem that you've got with a lot of the renewables are what you might call clean energies. If you take solar as an example, it's not particularly appealing to the digital infrastructure, and the reasons are simple. It requires a lot of maintenance, it requires a lot of land, and it's about 24% efficient. So it's not reliable enough for digital infrastructure for it to take it seriously. And that's what really drives data centers, our digital infrastructure, is it available at all times? And what is the impact of losing its availability on the businesses or the community or the wider world? So there's still a lot more work needs to be done. And there's still a lot more understanding about the technology and the safety of it. So I guess we've got to help organizations that are doing the R&D and the development of these products get the resources that they need to make public or the general business community comfortable of its safety and its reliability and its costs.
Yeah, and I think just trying to play back when Jason was explaining the difference between embedded and circular, I think if you've got any kind of power supply that sort of can change, you quite often try and solve that by putting it inside a battery. And obviously really large batteries probably have an embedded carbon impact, because you're having to create batteries for the first time. So it's this thing. Jason, also you mentioned physics, didn't you? So it's you can't create or destroy energy sort of problem where you're sort of going around a loop, and so you think you found something, but actually you look at it in the balance, and there's something else that's sort of holding us back. So Is there anything you see in the future from an energy point of view that could be a silver bullet? And by the way, Astrid, I don't want to leave the audience with any kind of silver bullet feeling, because I think it's the last thing we want to do, because it's a very, very real situation that we're facing. And we'll get into that just before we sign off. But Jason, are you aware, R&D side and people that are approaching you about some potential alternatives or breakthroughs?
So I think I sort of talk in my hopes and dreams in a personal capacity rather than what I may know what's going on elsewhere. But one of the I would like to see a closer link between sustainable sources of energy and the use of the electricity that produces, or the use of the energy that produces, to crack water for hydrogen. So we talked about storing the electricity in batteries, but another way of storing the energy is in the hydrogen gas. So and use that as that gas battery. 'Cause the problem we have currently with hydrogen, certainly in the UK and really the world as well, is the majority of it is not green. It's from cracked oil, and so it's still a valid use, but it's not it's not as sustainable as it could be. If we can crack water, then that's much more sustainable than using the oil.
Okay, and you use the phrase "crack water." I think what you're saying is that a lot of the hydrogen we're using is actually coming out of oil in the first place. So we're processing it out of oil rather than taking out of the H out of H2O, as it were. Okay,
it's exactly that. It's crack the chemical.
Got it. Understood. Thanks, Jason. So just
Can I just come in on that as well?
Go for
I
Astrid.
think the points that everybody's making are great. I would just add in that maybe our silver bullet is not just around different energy provision. Maybe our innovations should be around making energy efficiencies through things like combined heat and power, which Leo was talking about and Jason alluded to, with energy goes in, 99% is released in heat. So why don't we use that heat, and we have data as a byproduct of heat production? I think innovations around that are really exciting. And realistically, if we had as many of those as the renewable power side, then we're getting somewhere. Because even if we can generate all this renewable energy, we've still got a problem with energy footprint and energy demand. And like when we transition our car fleet onto an electric grid and our gas boilers onto an electric grid, we're going to see a massive increase in demand on electricity. So efficiency savings and innovations around that would be really, really, really exciting.
Brilliant. Thank you, Astrid. So I'm just thinking we've got 7 minutes to go. I've got a couple of things I want to make sure we cover off. One was just very briefly talk about quantum computing. The next one was I was just going to run through some sort of common climate scenarios that I'm aware of, just to give our audience a sense, if they don't know already, just how serious things are for us to do something. And then at the last point will be, just ask each of our panelists to give some takeaway points that they might want to leave the audience with. So very quickly on quantum. Now, quantum sounds like it's a little bit further down the road. I don't know what the power consumption is of quantum, but I do know from a compute point of view, if it delivers the vision that people are talking about, that it is order of magnitude seems to be an understatement in terms of what it will be able to do in terms of compute. I know it will have all sorts of other implications, like the way we do encryption at the moment won't necessarily work, and pretty much everything runs on that current form of encryption. But if we end up with a computing capability that doesn't take the proportionate power feed, that might be very helpful. There's lots of ifs and buts there, but I don't know if anyone on the panel has a view or has been able to Google whether or not quantum is very power intensive. A little bit like the earliest talk of blockchain. I'm not comparing quantum with blockchain, by the way, but people looked at blockchain and then you suddenly saw what the overhead was, and it's sort of become something that you wouldn't really want to do. So does anyone have a view on that, on the quantum side of things?
I do. It might be quite old, I went to a conference 3 years ago and they said that quantum has to operate at absolute zero. So your
Okay,
cooling
great.
infrastructure is significant on that. I don't know
Yeah.
if it's come on any since 2019, which is when
Yeah.
the conference was.
Okay, so what you're throwing in there is the 0 degrees Kelvin even, and that's going to require quite a bit of power to create that kind of atmosphere. Is that your point, Astrid?
Yes.
Yeah.
Yes, it is.
Okay. So again, we're back into so then I think we should get into what I personally think is a really important message for this session. So when I started looking at this area, not for today, but generally speaking, I was really surprised to be told that the scenario I should be looking at for the next 10 years is an increase in temperature between 1.5 degrees Celsius and 4 over the next 10 years. So you guys might say, oh no, John, that's the wrong scenario. That's the one I'm aware of. And when I ran the 1.5 degree scenario using, there's lots of tools online, you can see what happens to sea levels. 1.5 degrees is really serious. I mean, it is 1.5 isn't trivial at all. And then you start to get into the 4 degree category, and then things become a little bit, I suppose, that gold, Astrid, that you're talking about that just got landfilled. It will survive because it was born out of a supernova, but it won't be our species that will be using it. It will be something else. So what's I just don't want us to understate how serious the challenge we're facing. But do you guys work to any tolerances? Is the 1.5 degrees over 10 years something that you guys recognize, or is it 20 years, or what do we think's happening to climate best case at the moment? If we just take temperature. Anyone want to take
Is that 1.5 degree temperature rise by the end of the century?
Well, the scenario I saw was within the next 10 years. Now, if it's the end of the century, I don't want to have the effect of underplaying
we're
it.
at about 1.2 above pre-industrial levels at the moment.
Yeah.
And the aim is to get it to 1.5 by the end of the century. And if we achieve net zero by 2050, we have a hope of doing that in line with science-based targets. And then you would want a sort of midpoint in that for any net zero plans. Jason's probably got a better view on this in terms of government than I have on national targets. I think there is a depressing realisation that the pledges that we have at the minute from global governments, we are unlikely to hit that 1.5 degree temperature rise. It's likely to be more like 2.8, which we use in our training to articulate the fact that really it's businesses who have to boost that number. If everybody put in a net zero plan today, and we're able to achieve a net zero plan by 2050, we may have a hope of keeping that 1.5 degree temperature rise by the end of the century. I don't want to think about what happens if we can't. We know what 2 looks like, and it's fairly shocking. If we aim for 1.5, we've got a better chance of keeping it under 2.
Right.
2 degree temperature rise means that you lose all your coral reefs, for example. It's not a good place to be.
No.
4 degree temperature rise. We've got to factor in technologies that would mitigate the effects of climate change. That may kick in by the end of the century, which would enable us to adapt to that climate change potentially. But a lot of the species that we see around us will not survive that. And there are tipping points across the world that are likely to kick in at 2 degrees temperature rise by the end of the century. And then you've got a situation in which you risk having an ever-increasing temperature rise because you've lost your ice caps, boreal forest, and various other bits and pieces.
Yeah, and I think we can't trivialize this. And what I've heard is that in nature, if you push things too far, you create a new equilibrium, and that equilibrium is something that doesn't sustain life as we know it. So it is a very, very a serious message, and I didn't want to understate that because what we're doing is extremely serious. Just as a takeaway, for everyone who's listened, and I really appreciate everyone on the panel who's donated their lunch hour to this. If I just go through, maybe I ask Jason, then Leon, and then finish with Astrid, just as sort of the folks that are watching this and everything that we've discussed, what would be your kind of message that you'd want to get across in terms of, a strategy to adopt, or just some takeaways from everything we've discussed? What would your advice be to folks leaning in and listening to this? So, Jason, would you like to start that one?
Yeah, thank you. Very, very quickly. It's if you're running IT in your own facilities, or you've got a managed service provider that's doing the same on your behalf, and you're in public sector, or you're associated with the public sector supplier, come and talk to me. We can help.
Brilliant. Thanks, Jason. And Leon?
I mean, my suggestion would be everyone's business challenges are different and they've got different priorities. I'm not saying that one size fits all to solve those challenges to help them achieve their objectives around net zero or increasing their efficiency. But what we can do here at the Data Center Alliance is sit down with you, talk through what you're trying to achieve, and point you in the right direction of experts that can help you deliver on your promises. And that's what we can do. But our community is quite wide and varied with lots of different expertise. And through that community, we can support you in whatever your challenges are going forward.
Thanks, Leon. And Astrid, you gave a very powerful kind of view of sort of the future. What would you want to leave folks with in terms of the message you'd like to impart on the audience?
I think that everybody's here is great because they obviously care. My takeaway being value data. Don't think of it as an invisible resource that may be low cost, but it doesn't have a low material cost or low energy cost. And value equipment, even though it's lost its monetary cost, because it cost an awful lot to produce that equipment. So, try and think of it as a valuable resource that's worth preserving.
Fantastic. Thank you, Astrid. Thank you, Leon. Thank you, Jason. And thank you to everyone who's joined us this lunchtime.